Hello and welcome to Getting Started with Amazon Redshift webinar. My name is Pawan Potsukuchi. I'll be your presenter today. So here we have with us Vandale Sashim or Pop, who is a database engineer at AWS. Pop will be our Q&A moderator. A little bit about myself. I'm a principal product manager with Amazon Redshift. I help define the roadmap for the product, addressing needs from customers like you. Prior to this role, I spent 4 years with Amazon RDS and was on the founding team for Amazon Elasticache. Before we begin, I would like to walk you through a few items. On your screen, you can see a Q&A panel. Please submit your questions at any time during the webinar. Pop will answer as many questions as his time allows in the Q&A panel while I'm presenting. Towards the end of the webinar, there'll be a live Q&A session, and I'll go over some of the questions there as well. Lastly, this webinar is being recorded. We will share the recording and the presentation slides via email a few days after the webinar. So let's get started. So in this webinar, I'm going to briefly introduce what Amazon Redshift is, what are some of the use cases that we are seeing customers use it for, and also go through a brief demo about around loading data and getting started with Redshift. So we started Redshift with three simple objectives. It should be super fast, it has to be very cost effective, and it has to be very easy to use. And over the past 2.5 to 3 years since the product got launched, I think we have met those objectives. So Redshift is based on a massively parallel processing architecture, and it's columnar. It provides you the best of the breed hardware and software at a very cost-effective price of less than $1,000 per terabyte per year. It's very easy to get started. You can create a cluster with a few gigs and scale it up to petabytes as your needs and requirements grow. So it's a fully managed data warehousing service. It's SQL compliant. So any of the existing applications, BI applications that you use today will work seamlessly with Redshift. Here is a high-level overview of the big data platform at AWS. So we have services like DynamoDB and RDS and other transactional services that you can use to process your, to load your data. And we also have a new service, a relatively new service called Kinesis, through which you can stream real-time data. And you can use services like S3 and Glacier to store that data, and use analytics services like Redshift and EMR to analyze that data. So Redshift we are going to go over in this presentation. So EMR is a managed analytical platform based on Hadoop. And you can also use your own choice of data warehousing services on EC2 as well. And data pipeline is our orchestration layer through which you can move data across these various stages. So here is a high-level overview of some of the customers that are using Redshift. So you can see there are large enterprises, there are companies with lots of data in the social media and mobile verticals. NASDAQ, for example, loads 4 to 5 billion records per trading day into Redshift and uses it to analyze client activity. So NTT Docomo is one of the largest mobile operators in Japan. They have a petabyte-sized cluster with 100 plus nodes on Redshift. And so they have their transactional systems on premises, and they use a direct connect link to load data into Redshift and analyze log information. So we have Nokia that found their cost reduced by over 50% after they moved to Redshift, and their query performance double. Amazon.com uses Redshift pretty extensively, and one of the key use cases is around clickstream analytics. So FINRA is a financial regulatory agency in the US. They have a very large Redshift cluster as well, and they use it to analyze equity trades. So we have a rapidly growing ecosystem, partner ecosystem on Redshift. So we briefly talked about the SQL compatibility and the ability to use your choice of BI tools and ETL tools with Redshift. So you can use Informatica, Pentaho, Talent, and any of the other ETL tools. And we work with these partners very closely to ensure support and compatibility. You can also use BI tools such as Tableau, Looker, and others, and MicroStrategy to analyze your data and visualize the results. So we're going to go over some of the benefits of Redshift. So before that, let's take a quick look at the architecture. So Redshift, as I discussed, is based on a MPP-based architecture. So you interact, your SQL clients and BI tools interact with the leader node through JDBC or DBC drivers, and the leader node interacts with the underlying compute nodes that scale as your data grows. So the leader node stores the metadata of your tables, and it generates the ideal SQL plan after parsing through your query, and then pushes the execution logic into the compute nodes. Compute nodes is where your data resides in the columnar format. And you can parallelly load your data into the compute nodes from a variety of data sources, including S3, DynamoDB, EMR. You can also SSH directly into the compute nodes from your EC2 instances and load data. So the leader node and the compute nodes are connected through a 10 gig pipe. And so this ensures high performance when the nodes communicate with each other. The compute nodes also communicate with each other to distribute the data as you load it. We have two hardware platforms. One is based on hard disks, and the other is based on solid state drives or SSDs. So the SSDs offer 10 to 15 times more performance. However, they cost twice as much as 5 times as much as the hard disk based instances. So customers choose the platform that they prefer based on the cost performance requirements they have. We'll briefly go over the instance types in a bit more detail shortly. So we talked about Redshift using columnar storage. So what is columnar storage? What is the benefit of columnar storage? So it allows Redshift to significantly perform less I/O than some of the other comparable row stores. So when you're performing queries on a row store, you're getting all the columns, irrespective of whether you use them in your queries or not. Whereas in a columnar store, you only we only retrieve those columns that are participating in the query. Columnar storage also allows us to do very high levels of data compression. So imagine a gender column with just 2 fields. So you can achieve quite a bit of compression in a columnar format. And typically we see customers getting 4 to 8 times compression ratio with Redshift. So we have what we call as zone maps that allow us to retrieve data very quickly when you execute queries. So zone maps store the min-max values of each block and retrieve the fewest amount of blocks that are required to get you the data for your queries. So this minimizes unnecessary I/O. Redshift also uses direct attached storage, and the block size is 1 MB, so it's fairly large. So using direct attached storage enables us to perform scans at a very high rate. So we typically see scans in the range of 2 to 4 gigabytes per second. And the large block size allows us to make the most of each read. Redshift also manages durability for you. So we automatically do backups and enable you to restore data from any of your backups. We briefly talked about the two different hardware platforms we have, the dense storage and the dense compute nodes. So the dense storage offers you, starts at 2 terabytes per node, and you can scale it up to 2 petabytes by adding multiple nodes into your cluster. The dense compute platform starts at 160 gigs, and you can scale it up to 320 plus terabytes as you add more nodes. And so the cost for the dense compute nodes is about 5 times that of comparable dense storage nodes. However, they offer, like I discussed, 10 to 15 times more performance. So we have customers that use both these platforms. They store the hard data in the dense compute nodes and then lifecycle it into the dense storage nodes over time, and further move it back into S3 as the data gets older. Redshift is priced to let you analyze all your data. So we have um, seen customers struggling with the decision to figure out which data to keep and which data to throw. So this is something data engineers and analysts face on a regular basis. So the idea with Redshift is to offer you analytical horsepower at very cost-effective prices so that most of this dilemmas are not relevant anymore. So with Redshift, you can start with $1,000, less than $1,000 per terabyte per year, which is one of the most cost-effective platforms for analyzing your data in the market. So price, Redshift's price is for compressed data. So as we talked about earlier, so customers get quite a bit of compression when they bring data into Redshift. So your costs will be even lesser, depending upon the type of data that you're bringing in. The price also includes 3 copies of data for high durability. So Redshift has built-in security at several levels. So when you load data from S3, it's transmitted through SSL, and you can use SSL to communicate with the later nodes. There is encryption at rest, and we use envelope encryption. So each block gets its own key for encryption, and then the cluster key envelopes the block keys. And there's another key that envelopes the cluster keys. So the multi-level envelope encryption provides not only provides you high levels of security, but allows you to restore data very quickly because of the underlying mechanism of key management. You can also use HSM with Redshift. You can use your own HSM on premises, or you can use the cloud HSM service on AWS to manage the keys. Redshift also provides very granular audit logging capabilities. So it's also integrated with CloudTrail so that all your APIs are logged and can be analyzed at a later point. VPC support, of course, is a default for most of the AWS services today. We also have several compliance activities that we underwent, including PCI, FedRAMP, and HIPAA. So how does Redshift manage durability and availability for you? So Redshift backs up your data in increments. So if the data changes by more than 5 gigs, or if it has been more than a few hours since the last backup, Redshift goes and automatically does an incremental backup. There is replication within the cluster, and on S3, there are multiple copies of your data for high durability. Redshift also monitors failures on your um, data warehousing infrastructure. So if any of your nodes fail, we automatically detect it. And if you have a multi-node cluster, we automatically replace one of the failed nodes so that you can get started with your analysis very quickly. Redshift also offers cross-region replication, cross-region snapshot copy capability. So you can just turn it on and let Redshift manage copying of the snapshots across regions on your behalf. And you can restore the copied snapshot from the destination region for DR purposes at any time. So what are some of the use cases that customers are using Redshift for? So we have seen traditional enterprises use Redshift both as a replacement to their enterprise data warehouses. We've also seen enterprise customers use it as an extension to their existing data warehouse platforms, typically as a data mart. So what does it allow them to do? So it makes them move much more quickly. So they don't have to provision new hardware, they don't have to procure licenses, and it provides departments within enterprises more agility to analyze their data in their own pace. So we have also seen companies with social media companies, mobile companies with big data needs using Redshift very extensively. So we have seen customers use it as a replacement for MapReduce, Hive kind of use cases and get order of magnitudes more performance. We've also seen customers use Redshift and MapReduce based systems in a complementary manner. Use MapReduce based systems to process logs and move that data into Redshift for quick analysis. We've also seen software as a service companies use Redshift to add more analytical functionality to their applications. Here is a bit of a detailed example around how Yelp is using Redshift. So they have two different use cases. One is for analyzing their ad campaigns, and the other is for analyzing their mobile applications and how customers are using interacting with Yelp to the mobile devices. So on the ad side, they have tens of millions of ads per day, and they like to store up to 18 months of ad data so that they can analyze how ads have performed historically, how many clicks each had got, how many impressions, how did it lead to conversion, so that they can help their customers on the advertising side make better decisions. On the mobile side, they record up to I think 250 to 450 million mobile events per day, and they use Redshift to analyze the event data to understand how a specific feature is being used by Yelp's customers. And they also do quite a bit of A/B testing to understand how different cohorts are behaving and interacting with specific features. So let's go through an example of creating and scaling a Redshift cluster. So I've done this yesterday. So I'm going to walk through to it, and then we can start loading data after we create the cluster. So getting started with Redshift is very easy. All you have to do is go to the management console, specify a cluster identifier, port number, and the master username and password for your schema. And in the next step, you would specify what node type you want to use. So we talked about the two different platforms we have and the different instance types we have. So in this particular example, we have chosen a dense compute large node, and it has 160 gigs of SSD storage and 15 gigs of memory. The interesting thing about this particular instance type is it is part of the free trial program for Redshift. So you can get started today and create a Redshift cluster and follow through this example. Once you select your node type, you have to select the security settings for your cluster. So typically customers use VPC, and so you specify whether your cluster is publicly accessible or not. If it is publicly accessible, you can choose to include a EIP. If it is not, you can access the cluster through from your VPC or from outside through NAT. So security groups are an important security group is an important configuration. So if you are an AWS customer, you're probably very familiar with how security groups work. So with Redshift, if you're using VPC, you can select a VPC security group. And so you'll have to ensure that the IP addresses from which you're accessing the Redshift cluster are all whitelisted in the security group. If you're accessing through EC2 instances, you have to make sure that the EC2 instances are part of the same security group so that access is allowed. Or specify a different security group that corresponds to your EC2 instances as a rule in your VPC security group for Redshift. So that's typically the best practice. You wouldn't probably want to use your EC2 security groups, the application level security groups, and the database, data warehouse or database level security groups in the same context. You ideally want to have a tiered security group model where your app servers all have a different security group so that they may be exposed to the internet, whereas your data platforms, your transactional systems, your warehouses are all part of a private subnet that is not exposed to the internet. Once you specify your security group settings, you can look at the confirmation screen and then get your cluster launched. So you can also resize your cluster once you start loading your data, understanding the performance behavior and your requirements better. So we'll go through this on the console as well. So the resize operation happens behind the scenes, and the cluster remains online while you're resizing. We provision a new cluster in the background with the configuration that is required. So in this particular example, we're going from 3 nodes to 4 nodes. So the data needs to get distributed across 4 nodes now. So what we do behind the scenes is we provision the new cluster, we parallelly move data from the source compute nodes to the destination compute nodes and redistribute the data behind the scenes. So all of this is transparent to you. Your cluster remains online for access, but in a read-only manner. After you're done with, after the operation is done, you can go ahead with writes on the cluster, as you're only charged for the source cluster while this operation happens in the background. So what are the options to load data? So there are 3 different options that we're going to go over, and one of them, this particular option is what we're going to dive a bit deeper into. So you can use flat files on S3 to load data into Redshift. You can use a variety of ETL platforms, such as Informatica, Talent, Unity, SnapLogic, Hackers are some of the ones here, to transform your data before you load into Redshift. All these partners have connectors to Redshift. You can also load data directly from Kinesis. So if you have streaming data that you're using Kinesis for, there is a connector for Redshift with Kinesis as well. So let's go through a quick demo for loading data. So this is an example directly from our user guide. So you can follow along after the webinar and do it in a self-paced manner. So high-level schema, so there is a part, supplier, and customer table. They're all the dimension tables for the fact table, which is a line order table. So The orders are stored in the line order table and have references to the part, supplier, and the customer tables. So there is a date table which consists of information such as what are the different seasons associated with the date, so that you can do interesting analysis based on which products have been ordered in what season, etc. So I'm going to go into SQL Workbench. So this is one way to connect to Redshift. And typically customers use this for ad hoc queries, for executing ad hoc queries. So I have, let me go to my S3 bucket. So I have an S3 bucket called PP Redshift Webinar Demo, and then a folder called load in it, and a bunch of different files which has data in them. So the first table that we're going to load is a part table. So it's a CSV table broken into multiple files. There are 8 files corresponding to it. And loading data from S3 is a very simple operation with Redshift. So we have a native command called copy that allows you to do it. So in this particular example, all we're saying is copy into this table from this particular S3 file, S3 object. And I created a temporary user with very limited credentials. And I'll get rid of it after the demo. And let's execute it. I've already created the schema beforehand. Okay, I need to connect, sorry. So this is a connection window for the Workbench. I've used the Redshift driver. You can either use the Redshift driver or the Postgres drivers to connect to Redshift. We recommend the Redshift driver because it has performance benefits, and we've done some optimizations for it. And this is the Redshift cluster that I've created already and connecting through it. So this is a master user, and this is the master user password that has been specified in the previous flow. And connected to it. Now loading the part table. Okay, very quick. So it loaded about 50,000 records into the part table. And this is a CSV file. Let's take a quick look at how the file looked like. So this is a CSV file, has a bunch of fields in it, and now all these got loaded. So this particular copy command uses what is called as key prefix option. So when you specify an S3 bucket like this, what happens behind the scenes is Redshift picks up all the files with that prefix. So part CSV dot table, so there's part CSV dot table 000 to 007. So you don't have to specify each file separately, they all get picked up. So the next one we're going to load is the supplier table. So the supplier table belongs to a different bucket. It's not my bucket, but anybody can access it with AWS credentials, and it has been shared for the purpose of the user guide demo, so you can use it as well. Now this is taking a little bit more time, so 3 odd seconds. So we have 1 million records or so that got inserted in just 3 seconds. And this is a compressed file with gzip. Now the next one is interesting. It's a customer table, and we are loading it through a manifest file. So what is a manifest file? So if you use the key prefix option, like we used here in the part table, where we specified part csv.table, we could have done that, because the customer table has also has multiple parts, and we could have said customer fw.table as a key prefix. However, what that could have done is we have the 8 files here. In addition, we have some extraneous files with the same prefix. So one of them is a log file, the other is a backup file. Depending on where these files are coming from, it's possible that you could have some extraneous files. So what Redshift enables you to do is specify a manifest file which could have multiple S3 files as sources. So this is an example of a manifest file, which is a simple JSON object, and you just give it, excuse me. So you just give it a list of S3 files. They need not belong to the same bucket. You could have them split across multiple buckets. And now what it does is it's only going to load the files 0 to prefix 0 to 7. There are also a couple of interesting keywords in here. We have max error, we have accept invalid characters. So what this does is max error tells you, hey, don't stop when there is an error loading a particular record, keep going. However, stop after 10 errors so that you can go and inspect what happened and fix the errors, the load errors corresponding to these. So let's load this data. So this one is taking a little bit more time. So if you notice, there's a bit of a difference. The previous files had, so supplier file, for example, had delimiter, a particular delimiter character, and the customer file has a fixed width keyword. So what fixed width does is if you have a file, a source file, with records of fixed length, it'll use that length as a as a delimiter. So customer key is fixed at 10 characters, so you may have blank characters in it. CNAME is for 25 characters, address is 25 characters, etc. So copy command is very flexible. So you have several different options in it. So I would encourage you to explore it and understand how to use these keywords as depending on how your source files are, what data you have. You can also load JSON data directly into Redshift using the copy command. So it's not part of this demo, but you can explore that as well. And let's wait for this to complete. Oh, it did. Okay. So it loaded 87,000 odd records, and it had one record which underwent a replacement. So what accept invalid characters does is if there is an encoding format that's not compatible with the copy command, what it does is, or if it has special characters that are not compatible, it just replaces them with a different character. And in this case, it replaced it with the character. And so what the result is telling you is, hey, I've loaded 87,000 odd files. However, one record underwent a replacement because of the underlying character issues. And you can select data from STL replacements to see what that is. Let's do that. If there are errors, they would probably have been logged in STL errors file. Okay. So it's telling you this is a file, this is a line number, this is a column name which had the issues, which had the issue, and it had an invalid character. So you can go and debug it and see what happened. Let's go through loading another table. So this is the date table, and it has an interesting keyword called auto. So what that enables is for Redshift to interpret the incoming format. You could have your dates coming in different formats. So Redshift automatically interprets it and loads it into the canonical format. Sort of a convenience feature. Let's quickly look at what has been loaded in the DW date table. I would encourage you to not write select stars because, you know, it's not um, optimal in the real world scenarios where you only require specific columns. So it has a bunch of dates and associated fields. And like I said, one of the fields is the season, and it says, hey, this date belongs to this particular season. So you can do some interesting analysis when you load all the data. Okay. The next one is the line order table. And it has two different ways in which you can load the data. In this particular demo, we're going to just pick one way. So the first way is it has a single table, a single file. The other one is multiple files. So let's use a single file option. This is going to take some time, so we'll go through some of the slides quickly. So far what we have done is we have loaded the part table, we've loaded the supply table, we've loaded the customer table and the date table, and line order table is currently being loaded. So what's the advantage of using multiple files with Redshift? Remember that Redshift loads data into the compute nodes all parallelly. If you have an 8XL node, you have 16 cores or 16 slices as we call them. So each slice or core can go fetch a file from S3 and start loading it parallelly. So if you just have one file, your throughput could be limited to 6.25 MB per second, for example. Whereas you could, if you're parallelly loading data, you could increase it to 100 MB per second because you have 16 slices that can all start parallelly loading data. So you are better off, especially if you have multiple nodes and multiple um, um, and bigger nodes. You're better off taking advantage of the parallelism by having more files. So you can chop your data into multiple files. However, at the same time, we recommend that you batch them in a meaningful manner because each block size on Redshift is 1 MB. So you don't really want to put a lot of little files in it because there's some overhead for committing this data. However, do take advantage of the parallelism and make sure that you have multiple files. And the idea would be to have, as the number of files should ideally be a multiple of the number of slices you have in your cluster. So you have a 16 node 8XL cluster, 16 slice 8XL cluster. You would want multiples of 16, so 16, 32. 48, etc. as a number of files. So let's see if this completed loading. It did. So it took 47 seconds. So I've done this yesterday as well. So it took, about 48 seconds, roughly close. So this is with a single file. And with multiple files, with multiple files and with a larger cluster, the cluster currently that I have for the demo purpose only has one node. So I resized it earlier to 4 nodes and used the multiple file example to load the data, and the load was done in 17 seconds. So it's a huge savings from 50 odd seconds to 17 seconds. So imagine if you have So these are DC1.large clusters, which have 2 cores or slices per node. So if you're using an 8XL cluster, you have 16 nodes, 16 slices. And if you're using multiple 8XL nodes in a given cluster, you'll have multiples of 16 nodes. So you can achieve significant amount of parallelism and reduction in your load times if you have multiple files for loading your data. So how do you query Redshift? So we already did the client approach and loaded some files, and we also executed some queries on it. So you can use the SQL Workbench or other client tools to query Redshift directly. You can also use BI tools, as we discussed earlier, like Tableau, etc., to query Redshift. So one approach is the BI clients directly interact with the Redshift. However, as your scale grows, you're better off using a BI server and have your clients interact with the BI server and have the BI server interact with Redshift. Especially, this is especially important in cases where you have hundreds or thousands of users interacting with your analytics platform for canned reports. So Tableau, for example, has what is called as a extract um, that can preload the data in an pre-aggregated manner. And so when the dashboards need to load, they can directly get the data from the Tableau server. And if the period on which you're executing the queries, likely going to be recent, but you do want to go, if somebody wants to go into the historical time frame, then the dashboards can directly execute queries against Redshift. So this ensures that you get a lot more scale and parallelism when you're using BI tools. So Redshift provides you several ways in which you can monitor your query performance. So let's go to the console and see what happened with some of the load operations and selects that I executed. Before I do that, I'll execute a select query. So this is a join across the fact and all the dimension tables. I'm trying to figure out what orders came in summer. So we got a bunch of rows here. Okay. Let's go to the cluster. So this is the cluster that I've been using, and you have several tabs to monitor what's going on. So let's go to the performance tab. So you have a list of queries and what happened with it here. So this one is, so you see that the CPU utilization spiked up a bit. So let's see what was going on. So we were loading manifest file. So we were loading the customer table at that point. So there are multiple files, so there's a bit of a resource usage on the system. This is also, you also have a list of all the queries that have been executed on this so far. So let's look at the last one that we did. So this is the one that we executed just now. And you can click on it and go into what was going on when this query execution happened. So this is a query, this was the explain plan. So you can look at it before the query gets executed. And it tells what happened on the CPU utilization. It sort of went from 0.5% to like 2%. Not a big deal, but if you have more complex queries, you could see the resources being used more. Okay, and there's also another interesting tab which gives you the actual plan. What exactly happened when this query was getting executed. So it tells you time taken across slices and the average time for that. And you have a bunch of different operations that happened related to the joins. So we have think 4 different giants with the dimension tables, and it kind of tells you what was going on with each of them. So let's go back to, so we've gone through the query performance monitoring and went through the explain plans. So that sort of concludes the main um, topics of the webinar. So encourage you to go through the detail pages, go through the best practices. You can take advantage of the free trial and give it a shot. Give a shot to loading data, executing queries, and getting yourself familiarized with the Redshift functionality. We also have a deep dive webinar series coming up in July. So this was an introductory webinar. So as you learn more about Redshift, if you want to kind of get a better understanding of the best practices, how to optimize performance, how to use reporting tools, etc. with Redshift, I encourage you to attend these webinars. You'll get an invitation in a bit for these webinars. So we also have the Chicago Summit for those of you around the area coming up on July 1st. So it's going to we're going to go through 36 plus sessions, labs, and boot camps. So there's a Redshift presentation as well with a customer speaker. So if you're interested, I do encourage you to attend it. It's free of cost.